I'd appreciate it if you could support this channel by subscribing, liking, and leaving a comment. Also, make sure to turn on the notification bell so you'll be notified whenever a new tutorial is uploaded. Hello to all students and enthusiasts of the Data Structures course. Today we want to talk about algorithm analysis and step counting with a few examples. As our first example, suppose we are given this piece of code and asked to determine how many times each line of the program is executed. Let's start together from the first line. Nothing special happens in the first line. It's just a variable declaration that is not inside the loop, so it is executed once. The second line of the program is a loop, so naturally we need to calculate the number of times the loop repeats. To easily determine the number of loop iterations, let's consider a range from 1 to n. Then examine the loop condition yourself. See what values this range from 1 to n includes extra, or what values it is missing. Now, if you pay attention, you'll notice that my loop starts from 0 instead of 1. So I have an extra 0 at the beginning. That means at the start I have a 0, and at the end it stops exactly at n. And since it includes equality, n itself is also counted as an entry into the loop. So altogether that range from 1 to n that I set has n numbers. And I also have one extra 0 in this loop. So it becomes n plus 1 entries into this loop. Since after all the entries are done, one last time I is incremented, the loop condition is checked, and because the condition is not met, it exits the loop. So the statements related to the loops themselves are always executed one more time than the number of their entries. That is, here in this loop we have n plus 1 entries. And one time the final condition is checked and it is not satisfied. It exits the loop. So the total number of times this statement is repeated is n plus 1 entries, plus the last time when the condition is checked is not satisfied and the loop is exited. But all the statements that are inside the loop are executed exactly n plus 1 times. That is, we no longer consider that extra one for them. So this statement is executed n plus 1 times, and the last statement, since it is outside the loop, happens once. If we add these together, it becomes 2n plus 5. That is, our Tn, which is the execution time of the algorithm in terms of n, becomes 2n plus 5. And we know that to calculate the complexity, it is enough to assume that n approaches infinity. So, constant numbers lose their significance compared to infinity and are eliminated. Therefore, here as well, the 2 and the 5 are eliminated, and we can practically say that the complexity of this code segment is of order big O of n. Let's look at another example together. It says, suppose in this example n is greater than 1. In this code snippet, before we enter the while loop, the counter I is initialized with the value n. Since we know from the question that n is greater than 1, with this knowledge, we check the while loop. The loop condition says that I should be greater than 1. Since we know that I has been assigned the value of n, and n, according to the question, is greater than 1. So the loop condition, meaning I is greater than 1, holds true. We enter the loop. The loop step says to calculate the remainder of I divided by 2. Since we know that the remainder of a number divided by 2 is either 0 or 1, if the number is even, the remainder is 0, and if the number is odd, the remainder is 1. So the values that I can take in this line are either 0 or 1. Next, we move on to the following instruction. 1 unit is added to x. Our work is done. We complete one iteration of the loop and return to the while line to check the condition again, so that if it still holds, we enter the loop once more. The condition says that I must be greater than 1, as we saw earlier, since I was calculated as the remainder when divided by 2. So now our I is either 0 or 1, which in either case is no longer greater than 1. So the condition is checked, it doesn't hold, and we exit the loop. In the end, we can say that the first line, since it's outside the loop, runs once, and the while line itself runs twice. Why? Because it checks the condition once. It enters the loop, and the second time it checks the condition no longer holds and it exits the loop. The statements inside the loop are only executed the first time, and the second time, since I takes the value 0 or 1 and is no longer greater than 1, they are not executed. So in total, the number of times the lines in this code segment are executed is 5. If the number of times our lines are executed becomes a constant number, no matter what that constant is, whether it's 5, 10, 1 million, or 100 million, as long as it is a constant number, we say that the program or that code segment has a complexity of big O of 1. Let's go over the third example together. Again, we've been given a piece of code and asked to determine how many times each line is executed. The first line, since it's outside the loop, is executed only once. Regarding the loop, we said to imagine a certain range, which I've now drawn for you. I check to see what the starting value of my loop is now. We see that its initial value is set with I equal to 3. That means at the start of the loop, we don't have 1 and 2. Let's check the end of the loop. We see it says I should be less than n. It doesn't include equality. That's why for I feature n doesn't enter the loop. So at the end of the loop, we also don't have n. This range originally included n values. Now 3 of them have been crossed out in red. The number of remaining terms is n minus 3. So this loop runs n minus 3 times. Since we said that the loop line itself is checked one last time and the condition doesn't hold, we need to add 1 to the number of entries. So this line is repeated n minus 3 plus 1 times. No matter how many statements are inside the loop, their number of executions will be exactly n minus 3, which here we consider for the line temp plus equals 10 as n minus 3. And finally, the last statement is executed once because it is outside the loop. If we sum up these repetitions, it becomes 2 and minus 3. We said we remove the constant numbers. What remains, that is, the dominant term, is n. That is our order of complexity. Now, the dominant term in this sum is n, so this part of the program will have a complexity of n. Let's go through the fourth example together. We are given 2 nested loops with a single statement inside both loops. First, let's determine the number of iterations of the first loop. We see that our first loop starts exactly from 1 and ends at n. Why? Because in our condition, we have I less than or equal to n. So exactly the range from 1 to n is observed here, and we have n entries. The loop condition is also checked once. So in total, it's n plus 1. Now for the second loop, which is nested inside the first loop, first we need to consider the number of entries from the first loop, which is n times. Then we have to multiply this n by the number of iterations of this for loop itself. Let's check this for loop itself. We see that our range starts from 3, and in the end, j must be less than n. That means for n itself, there is no entry into the loop. It's just like the previous example. So from the range 1 to n, the values 1, 2, and n itself are not included. Therefore, we have in minus 3 entries into the loop. And the condition is checked once as well. So in total, it becomes n times n minus 3 plus 1. For the statement inside the 2 nested loops, the exact number of entries for both loops must be multiplied together. We said the first loop runs n times and the second loop runs n minus 3 times. So the number of repetitions of this line is n times n minus 3. If we calculate the sum of these repetitions, it becomes 2n squared minus 4n plus 1. If we remove the constant numbers, we are left with 2 terms, n squared and n. Since n approaches infinity, we need to consider the dominant power. That means the power of n compared to n squared loses its significance, and the influential term in this set will be n squared. So in this example, the order of our code segment becomes on squared. Let's go through the fifth example together. In this example, our first line is again outside the loop, so it only executes once. The second line is a loop that starts from 0 and goes up to and including n. So in that range from 1 to n that we were supposed to consider, we actually have 1 extra iteration because of the 0. So that's n plus 1 iterations, and the loop condition is checked one more time, making it a total of n plus 2 times. For the second loop, our range is from 2 up to n minus 1. That means if I consider the range from 1 to n again, at the beginning I don't have 1, and at the end I don't have n minus 1 or n. Why is that? Because our condition says j should be less than n minus 1, meaning it doesn't include n minus 1 itself. So we don't enter the loop for n minus 1 nor for n. Therefore, these 2 terms are removed from the end of the range. The entire range has n terms, 3 of which are crossed out, so we're left with n minus 3 terms. So the number of times this command is repeated is n minus 3 plus 1. This expression is multiplied by the number of entries into the first loop. Why? because the second loop is inside the first loop. So in the end, it becomes n plus 1 times entering the first loop multiplied by n minus 3 times entering this loop plus 1, which is the last time the loop condition is checked, doesn't hold, and we exit the loop. The statement inside the two loops is executed exactly as many times as the product of the number of entries into the two loops. The number of entries into the first loop is n plus 1, and the number of entries into the second loop is n minus 3. When these two values are multiplied, they give us the number of times this statement is repeated. The next statement is only inside the first loop. If you pay attention, the scanf statement and the second for loop are aligned, which means that the scanf statement is not inside the second loop, but is only a subset of the first loop. So for this statement, we only need to consider the number of entries into the first loop, which is n plus 1 times. Finally, the last statement is outside the loops. Its number of repetitions is 1, so if we sum up all these repetitions, we get 2n squared minus n. The influential term in this sum is n squared. Therefore, the complexity of this code segment will be big O of n squared. Let's go through another example together. Here, we have two statements that are outside the loop and each of them is executed once. Then we get to our loop. We have a while loop. Outside the while loop, our counter is initialized starting from 1, and next to the while statement we have our condition, which says I is less than or equal to n. The loop increment is also inside the loop body, where it says I increases by 1 each time. So our range starts from 1 and goes up to exactly n. So we have n iterations plus 1 time for checking the condition, making a total of n plus 1. For the statements inside the loop, we have an if statement that is checked exactly as many times as the loop runs, which is n times. But the point here is how many times the statement inside the if is executed. The statement inside the if only runs when our condition is true. Since we want to calculate the complexity of a piece of code in the worst case scenario, we need to see how many times this statement is executed in the worst case. The worst case scenario happens when every single element of our array is equal to k. That is, every time the if statement is executed, the condition inside the if is true and we enter the if block. This means that in the worst case, the statement inside the if is executed n times. Again, I should mention that in many cases, this number of repetitions may be less than n. But when we want to calculate the complexity, we consider the worst case scenario. And here, the worst case scenario is when the if condition is always true and the statement inside the if is executed in times. The I++ statement is also executed at most n times, and the last line is outside the loop and is executed only once. If we sum up these repetitions, we get 4n plus 4, where the dominant term here is n. So this code segment is of order n. Let's go through another example together. This example is very similar to the previous one, except that the statement inside the if is different. So the first two lines that are outside the loop are each executed once. The while line is executed n plus 1 times, since it runs once for each entry into the loop. And the condition is ultimately checked one more time, making it n plus 1. Each time we enter the loop, the condition related to the if is checked, so the line with the if statement is executed n times. An important point here is the statement inside the if. The statement inside the if is not a regular statement like in the previous program. Here, it actually returns a value. We know that when a return occurs, the function completely ends and we go back to where the function was called. So if the if condition is true and we want to execute the statement inside the if, a return happens and the function effectively ends. Therefore, the maximum number of times this statement can be executed is just once. The very first time the condition is true, we enter the if and the return statement is executed. But if we want to consider the worst case scenario for this piece of code, the worst case happens when the if condition is never true. This causes our while loop to execute completely for n times. If the if condition becomes true before all n iterations are completed, since the return statement is executed, the rest of the while loop is abandoned midway and we exit the function. So this cannot be the worst case scenario for this algorithm. And in order to determine the worst case scenario for this algorithm, we have to say that the number of executions of this line is 0. I wrote a 1 in parentheses next to or. What I mean is that it can also happen once, but 1 is not the worst case scenario for this statement. And if we want to consider the worst case, the I++ statement must also be executed exactly n times. That is, the number of iterations of our while loop should be completed fully. In the end, we exit the while loop and the final return happens once. For the final return, I considered the value 0 in parentheses. This means that the return might have happened inside the if statement. If that particular event has indeed happened, then I will not reach this specific return statement outside of the main loop. But the worst case is when the return does not happen inside the loop. The loop runs completely n times, and finally, with the return outside the loop, the function ends. Now, if we add up the number of these repetitions, it becomes 3n plus 4, which shows that in the worst case, the order of execution of this code segment will be O of n. Let's look at another example together. In this example, we first have a for loop. Our for loop starts from 0 and goes up to n minus 1. If we consider the range from 1 to n, at the beginning of the range we have one extra 0, and in return the end of the range doesn't end at n but rather at n minus 1. So we have an extra 0 at the beginning, and in return we don't have n at the end of the range, which means by adding one term at the start and removing one term from the end, we still end up with n terms in total. Therefore, the number of times this loop is entered is n, and the condition is checked one more time at the end, so the total number of times this statement is executed is n plus 1. The statement inside the loop is executed exactly n times, and after that we reach the second for loop, which is nested inside the first for loop. This loop is not a regular loop. If you pay attention, this loop depends on the first loop. Why? Because its counter starts from 1 and goes up to I. I is the counter of the first loop. Each time the first loop takes on a value, the second loop will repeat based on that value. Now what we need to do is check what values the first loop assigns to I. The first time our I becomes 0. So for our second loop, the values for j will be from 1 to 0. For j from 1 to 0, the loop condition is not satisfied. So it won't enter the loop at all. It just checks the condition once, and since it's not satisfied, it exits the loop. So the first time when I is 0, this line is executed only once. It checks the condition once, but it's not satisfied at all. Entering the loop does not happen. Then I becomes 1. When I is 1, our second for loop becomes j from 1 to 1. For j from 1 to 1, it enters the loop once. The second time, j becomes 2, and since the condition is not satisfied, it exits the loop. So for I equal to 1, the number of times the second loop statement is executed is 2 times. So this one that I wrote here is for I equal to 0. The 2 is for I equal to 1, where it enters once for j equal to 1. Then it sets j to 2, checks the condition, meaning this line is executed one more time. But since the condition is not satisfied, it exits the second loop, so the total number of repetitions is 2 times, 1 entry or 1 condition check. Then I becomes 2. So in this case, the second loop runs for j from 1 to 2. It enters for values 1 and 2, and for value 3, this line is executed again, but the condition is not satisfied. So it runs 3 times for I equal to 2. And finally, when I equals n minus 1, for values from 1 to n minus 1, we enter the loop, which happens n minus 1 times. We also check the condition one more time, so n minus 1 plus 1 ultimately becomes n. We place this n at the end of the process. Now, if I want to find out how many times the command inside the loop is executed, I just need to subtract 1 from each of these terms that I summed up here. Why do I do this? Because in these terms, that final condition has already been counted once. So for the command inside the loop, I need to subtract that one instance of the condition from all these values. So when I is equal to 0, there was no entry into the loop at all, so it becomes 0. When I is equal to 1, we have one entry from the second loop. So this command is executed once. And in the same way, when I is equal to n minus 1, the number of entries from the second loop is exactly n minus 1 times, which is what we wrote at the end here. Finally, this command that is outside the second loop is only part of the first loop, so it repeats n times. And the last line, which is outside all the loops, is executed just once. If we calculate this sum, we arrive at this total. This fractional value n times n plus 1 divided by 2 is the sum of the numbers from 1 to n, which we know the formula for. N times n plus 1 divided by 2. The second fraction, meaning n minus 1 times n divided by 2, is the sum of the numbers from 1 to n minus 1. If we ultimately calculate this sum, the dominant term in this sum is n squared. So the complexity of this code segment is of the order of n squared. I tried to solve a variety of examples, each of which contains a specific point. I hope it has been useful for you. Have a good day and goodbye until the next video.